If you've managed to hang around until part F, then these are the easiest 5 marks you'll ever find in paper 3. It's like taking candy from a baby. Although, actually, you should take candy from a baby. I have babies. Who gives babies candy, right? So, let's have a look. If f of x is an even function, then we know, then its Maclaurin expansions contains only even powers of x. So, we've got f of x even, which means that f of minus x is equal to f of x. That's even, okay, even function. Okay, and here we're on the first level. So what's going to happen at f of the first derivative? Because remember, just like before, we need to work out what the Maclaurin expansion is going to be. I'm going to paste this in here from the formula booklet. Now in our situation, we are asked to show that it's got even powers only. So we're being asked to show that basically all these odd powers here, for example, like x cubed over 3 factorial, third derivative, etc., they should all disappear because they should all be 0. So we should only be left with the even powers. So let's have a look. Let's try and prove this. So f of 0, would it still be there? Well, yeah, because f of minus 0 is equal to f of 0. So you can't say that there's 0. You can't actually work out what that is, but that's definitely not 0. So let's take the first derivative of this. If I differentiate this, I need to use chain rule because I've got this composite function. I've got something other than x inside the bracket. So if I differentiate minus x, it's going to be minus 1 times by the derivative of x. If I differentiate this, I've got just f dash x. You guys know the drill by now. We're going to be evaluating all of these functions at 0 to work out what you would plug in here to Maclaurin expansion. Okay, so but again, I can put both of these derivatives on the same side, okay? And you already know this, guys. This is going to be the first derivative is going to be equal to 0, which means this is going to be x times 0, which means this is going to be x equals to 0. And this pattern is just going to keep repeating, because if I start here, okay, and I take the next derivative, well, I've already got a minus 1 there, okay? Ooh. Did I lose a minus x here? That was a bit naughty of me. So if I differentiate this, I've got the minus 1 there. When I use chain rule here, I'm going to get another minus 1, okay? And that's going to be times with the second derivative of minus x, which is equal to the second derivative here of x. Because remember, this is odd, and odd differentiates to even. So we know, I didn't even really need to do it. We know that the second derivative is going to be even. And an even function evaluated at 0 isn't 0. But if I look at the third derivative, okay, we know that an even function here differentiates to odd. So you can do it out, but we can just go a little bit faster now. We can just sneak through and go a bit faster here, guys, now. So we know that this is going to differentiate to an odd function. And whenever you evaluate this at 0, you're going to get the same pattern that we've been looking at here, which is that I can put both these third derivatives here on the other side together, and that's equal to 0. So 2 times the third derivative is equal to 0. Okay, so I know that all of my odd derivatives are going to be equal to 0, and that means that when I plug it in here, for example, that is going to be equal to 0, and then I'm going to get x cubed over 3 factorial times by 0. So that's just going to cancel out because it's going to be times by 0. So this pattern is going to keep repeating, right? Even will differentiate to odd, and when I evaluate my odd function at 0, it's going to be 0. So what's going to be left? Only my even parts of this are going to be left. So I'm going to be left with a function that looks something like this. F of x is equal to f of 0 plus f double dash of 0 times by x squared over 2 factorial. The third derivative is going to be 0, so that's going to disappear, right? The next one that will be there will be 4 over 4 factorial times by x to the 4. Okay, and the function is just going to continue on like that. If you were able to stick around for the whole of the paper 3 question, good job. You're a champion, you're a superstar. Post comments below what you would like me to do next. Have you found a really cool paper 3 question that you would like me to do? Post it in the comments below because I will be reading them. I'll see you later, guys.